Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson Best Practices in Data Design. Best practices in data design are essential for ensuring the integrity, usability, and efficiency of data systems. Data models are at the core of data management, serving as blueprints for how data is stored, accessed, and manipulated. Effective data design is crucial for enabling organizations to leverage their data assets fully. This lesson will explore the principles and methodologies that underpin best practices in data design, supporting the goal of creating reliable and efficient data models. Data design begins with a thorough understanding of the business requirements. These requirements inform the data model, ensuring that it aligns with organizational goals and processes. One of the primary principles of best practices in data design is normalization. Normalization involves organizing data to minimize redundancy and dependency, facilitating data integrity and efficiency. The process typically starts with the identification of entities, attributes, and relationships, leading to the creation of an Entity-Relationship Diagram. An ERD visually represents the data structure, making it easier to identify potential issues and areas for optimization. Normalization often follows a series of steps called normal forms, each progressively reducing redundancy and improving data integrity. First normal form eliminates duplicate columns from the same table and creates separate tables for each group of related data. Second normal form removes subsets of data that apply to multiple rows of a table and places them in separate tables. Third normal form eliminates columns not dependent on the primary key. Adherence to these forms helps in maintaining a consistent and reliable data model, which is crucial for data integrity. However, over-normalization can lead to excessive complexity and performance issues. Therefore, denormalization might be employed strategically to improve read performance. Denormalization involves the combination of tables or the introduction of redundancy for optimization purposes. The key is to strike a balance that aligns with the specific needs of the application and the anticipated query patterns. This approach requires a deep understanding of both the data and the ways in which it will be used. Another best practice is to establish clear and consistent naming conventions for tables, columns, indexes, and other database objects. Consistent naming conventions enhance readability and maintainability, making it easier for developers and analysts to understand and work with the data model. Naming conventions should be descriptive and follow a logical structure, avoiding abbreviations and acronyms that may be unclear to others. This practice supports collaboration and long-term maintenance, reducing the likelihood of errors and misunderstandings. Data integrity constraints are also vital in data design. Constraints such as primary keys, foreign keys, unique constraints, and check constraints enforce rules that maintain the accuracy and consistency of the data. Primary keys ensure that each record in a table is unique, while foreign keys establish relationships between tables, enforcing referential integrity. Unique constraints prevent duplicate values in specified columns, and check constraints enforce domain integrity by limiting the types of data that can be stored in a column. These constraints are essential for maintaining the reliability of the data model. Indexes play a crucial role in optimizing the performance of a database. They allow for faster retrieval of records by providing quick access paths to the data. However, while indexes improve read performance, they can negatively impact write performance because the database must update the indexes whenever data is modified. Therefore, it is important to use indexes judiciously, balancing the need for fast query performance with the overhead of maintaining the indexes. Proper indexing strategies can significantly enhance the efficiency of data retrieval operations. Documentation is another cornerstone of best practices in data design. Comprehensive documentation provides a detailed description of the data model, including the purpose and structure of each element, the relationships between elements, and any constraints or rules that apply. This documentation serves as a reference for developers, analysts, and other stakeholders, facilitating understanding and collaboration. It also aids in troubleshooting and maintenance, ensuring that changes to the data model are made with a clear understanding of their impact. Security is a critical aspect of data design. Ensuring that data is protected from unauthorized access and breaches is paramount. This involves implementing access controls, encryption, and auditing mechanisms to safeguard sensitive information. Access controls define who can view or modify data, encryption protects data at rest and in transit, and auditing mechanisms track access and changes to the data. These measures are essential for maintaining the confidentiality, integrity, and availability of the data. Scalability is another important consideration in data design. A well-designed data model should be able to accommodate growth in data volume and user load without significant degradation in performance. This involves designing for efficient storage and retrieval, as well as considering future needs and potential changes. Techniques such as partitioning, sharding, and the use of scalable architectures like distributed databases can help ensure that the data model remains performant as the system scales. Another best practice is to incorporate data quality measures into the design process. Data quality is critical for ensuring that the data is accurate, complete, and reliable. This includes implementing validation rules, data cleansing processes, and regular data quality assessments. High-quality data is essential for making informed decisions and achieving business objectives. Data quality measures help to identify and correct errors, inconsistencies, and inaccuracies, ensuring that the data remains a valuable asset. Moreover, involving stakeholders in the design process is crucial for success. Stakeholders, including business users, developers, and analysts, provide valuable insights into the requirements and use cases for the data. Their input helps to ensure that the data model meets the needs of the organization and supports its goals. Regular communication and collaboration with stakeholders throughout the design process help to identify potential issues early and ensure that the final data model is fit for purpose. Performance optimization is another key area in data design. This involves identifying and addressing potential performance bottlenecks, such as inefficient queries, poor indexing strategies, or suboptimal data structures. Techniques such as query optimization, index tuning, and the use of materialized views can help to improve the performance of the data model. Regular performance monitoring and tuning are essential for maintaining optimal performance as the system evolves. In conclusion, best practices in data design are essential for creating reliable, efficient, and scalable data models that meet the needs of the organization. These practices include normalization, strategic denormalization, consistent naming conventions, data integrity constraints, judicious use of indexes, comprehensive documentation, security measures, scalability considerations, data quality measures, stakeholder involvement, and performance optimization. By adhering to these best practices, organizations can ensure that their data models support their business objectives and provide a solid foundation for data management and analysis. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.